Thank you very much, everyone, and thanks for joining in. Welcome to Notes 2021. We're going to talk about a very interesting project that we undertook over the last summer. So, as you can see it on the title, the world chooses mask and we choose the knowledge graph. Just to fight COVID-19. As all of us are aware, what happened, the world has completely changed from March 2020 onwards. I just wanted to introduce just quickly the team. Myself as Arshad Khan, I'm a senior data scientist. With me are my colleagues Shyam and Salman. We are part of a company called Ilm. It's just pronounced as Ilm. It's based in Riyadh, Saudi Arabia. Elm basically provide digital solution services, custom-based and ready-made solutions to various organizations, whether it be healthcare companies, automobile, immigration, border control. And we are particularly part of a research and innovation department who basically are focused on resolving some complex engineering problem by exploiting emerging technologies, AI, Neo4j, Graph, and these efforts of like developing on this, working on this project was part of those efforts to contribute to the local community and international front to fight COVID. So just to quickly run through the agenda is just to kind of storyboard it that we were facing that problem as every one of us were facing, and we wanted to contribute as a research team. So I'm going to run through the questions, the kind of research question we consider, and the brainstorming ideas the whole team basically went through in search of finding a solution and our contribution, obviously. And knowledge graph basically was at the heart of all of these discussions, and obviously our efforts then basically culminated at the development of an app, which is what we call Himaya app. So we'll tell you about that, and then this will be then followed up by a live demo in which my colleague will basically show you exactly the whole thing into action. And obviously, we will definitely share with you the lesson learned as well, like our experience and reflection, and obviously our current tell you a little bit about the current ongoing projects as well, in which we are heavily using Neo4j and Graph. So as I said earlier on, the problems was kind of like, I mean, these are the three words: crisis, uncertainty. I think they are the least. They are still not enough to describe that kind of problems, which basically put a huge strain on the hospital system and the healthcare system across the globe, really. So Saudi Arabia was not alone. Basically, as we all know, the demand was really linear, and the spread of the virus was exponential. So we wanted basically to come up with a system which can straight away basically help out the authorities, especially in identifying the people with COVID-19 statuses, whether they are positive or negative. And we wanted to use the technology basically to help ourselves and to put everything together basically in something more useful that could be used out of the box. So that's that was the vigor, and that was the motivation basically behind all this to kind of be part of this global initiative, and everybody was looking forward to it. Moving forward, basically, then to synthesize that kind of like motivation into a research problem. These are the three basically big research problems, like how to track contact of contacts who could be the possible spreader of the coronavirus in order to mitigate the spread and the rate of COVID spread. And obviously the social distancing, how to come up with some algorithm with some computational scoring mechanism of computing the risk and the social distancing, which could help us prioritize a certain section of this community, of society, for mass testing, like for COVID-19 testing, and to identify the chain of super spreader, which would then help us basically to separate the high spreader community from the low spreader community in the Riyadh region. So Riyadh, basically, in which we are based in, is like a big province. It's the capital, obviously, of Saudi Arabia. So all of these efforts were going into right direction, basically. Um, so after having had these problems and brainstorming ideas and the research questions that we kind of like deliberated and debated amongst ourselves, we were then faced with which stack of technology or which direction to move to. Shall we go on a more kind of legacy systems using just the RDBMS. But obviously, when it comes to, like as I said earlier on, we were supposed to focus more of the detection of context of context of context. Then that's where the legacy system were basically falling short of meeting those requirements. So we needed something which could just help us in that context, and Graph was basically Graph stood out, New4j, basically to help us tackle all those three big research questions: identify the contact of the person who is the spreader, and then to kind of like to kind of identify that cluster of people in a certain community for us to kind of like ring fence them and to help the authorities to basically prioritize their mass testing. So all of this basically then led to this knowledge graph based contact tracing. So as you can see in the graph, the red and the yellow. So the red is basically a person who is COVID, who tested COVID-19 positive. So so the app that I was talking to you about earlier on, that was supposed to tackle this kind of like relationship, and on the basis of those relationship, we wanted basically to kind of like address those three research questions which I showed earlier on. And then obviously you can see here, this is the analytics part where once a person tests positive, then we wanted basically to show the things into an analytical framework so that we can see which part of the region were more vulnerable and which part of the city basically needed prioritization and so on and so forth. And obviously then to put it all together into an app to so that the health authorities can straight away use it. So you can see now here there are two relationships. One is the Met and one is the Met event. So the Met event is basically anything like a daily life event. For example, you're going to a shopping mall, you're going to a surgery, to a healthcare center. You are going to a barber shop, thing like that, and then you came across with a person potentially. Are you going to the airport? Someone coming from there from another country, and you came into contact with them, and that means you have met them, and that means you are now carrying it and you are spreading it. So that was basically the whole point of like capturing that through this through that through a potential proposed application, mobile app. So then I mean, we call it the Himaya. So Himaya basically in Arabic means the protection and the support. So it's basically a solution for literally tracing efforts and prioritization efforts of the population in the face of an outbreak, which was COVID-19. So the general features included basically how to identify the high-risk individuals. That's number one, like starting with the person, and then to identify the high-risk localities. Obviously, the person makes utilities, and then to pinpoint the super spreader and to compute basically the social distancing based mass testing of the individual in certain localities, so that we can highlight them for the health authorities to take action. My colleague is going to talk to you about the whole architecture, what basically goes behind it, and I'll now hand it over to my colleague Salman from this point onwards. Thank you very much.
Thanks, Ashad, for the brief introduction. Hello, everyone. I'm going to explain the methodology and the system architecture of Himaya. To give you a clean, complete picture, I will start with the Himaya mobile application and explain how we are gathering the data. So each mobile app is transmitting a temporary unique ID via Bluetooth Low Energy packets, which is being changed after a few hours. And we are changing the unique packets for privacy purposes. Each mobile phone is also scanning for nearby Bluetooth packets, which are from the other mobile phones which are using the same application. So the Bluetooth IDs are also captured whenever two or more mobile phones are nearby within 2 meters range. This we are filtering through the received signal strength of the Bluetooth packets. Once the unique ID is processed by the application, we collect GPS coordinates of a mobile phone where the packets are exchanged and pushed it to the backend server where we have Kafka as a messaging queue to manage load and the number of packets. The metadata of the packets are stored in MongoDB and the information packets are fed to the knowledge graph. Once we process it, it is accessible for the health authorities on the dashboard. Uh, these are the technical details of our architecture. Our architecture is divided into multiple layers. For the mobile app development, we are using Android native, and we have done some extensive testing to reduce the battery consumption while using GPS and Bluetooth without compromising on the performance of the application. Using Kafka and new 4G JavaScript drivers, we were able to handle large amount of data and build messaging system that was able to feed BLE and location packets into the new 4G graph. On the knowledge graph, a person node is created after the user is registered in the system, and this data is used to populate the knowledge graph and visualize using the tools such as Bloom and new map. My colleague Shyam will further explain what we were able to create with the knowledge graph, leading with a wonderful demo. Thank you.
Yeah, so thanks Salman and Arshad for explaining the architecture and overview of the Himalaya app. So now I'll talk about how we leverage Neo4j in our Himalaya app. So one of the good things we use Neo4j for finding direct contacts of COVID positive person. Then we were able to see the second and third level of contacts. It's like a chain of people. And we implemented two unique algorithms for social distancing score that is more like a page ranking algorithms in a graph. We also use a risk propagation score that is like label propagation algorithms. So that I will talk in the demo time. Even we build a comprehensive COVID tracing reports for health authorities so that they can understand the mass behavior at large scale. So what our thoughts on Neo4j is Neo4j is globally accepted, so that build a trust to try the particular solution. It's scalable, secure, and productivity is very high. Especially, we were impressed with the how it was handling the Bluetooth packets at large scale. It has a very active community, so we get a lot of support during the development, and Neo4j Graph has data science and machine learning supports. And I believe this is where the future lies. And Neo4j offers simpler syntax and friendly ID. It means that you need not to be a data scientist to start working with the Neo4j. Even the basic understanding of graph will lead out to talk about to use the Neo4j. And if you want to bring the certificate, bring to the professional level, then we can use the certification also. So now, to make our talk very interesting, we use live demo, and I will talk about the use case. So just I'm going to share my screen, and then I will show you the. So our application is divided into four categories measure. We analyze the individuals, and we analyze the locations. So let me just start with the schema of our graph. So Bloom offers you the near natural search. So you can create the search phrases that you can see. So this is our actual the graph schema. So if you see here, the person node is actually created when a person is registered into the mobile app. And there is a positive nodes which talk about when a person is declared positive by the health authority. So we created another level when a person meet each other using the Bluetooth packets, or when they come in the contact of within 2 meters, then the met relationship is formed, and the event will be fired that record the time of event and where they visit. So that particular event is captured by the place node, and the relationship will be found visited. And there is a two types of place node. One is outbreak area, which if health authority has declared it as outbreak, so that will come. And there is another node that called as a country, where if people are traveling, then that will be shown. So now let's see what are the nodes available in our graph. So one of the good thing I like about the Neo4j is It's very vibrant, and if you see the animation, that's really good. It makes us fascinating. So, and one good thing is that from a single view, we get a lot of information. So, for example, if you see here the red notes, especially the red person notes, so these people are positive in a COVID in a knowledge graph. These yellow notes, yellow person notes represent that these are not positive people. This particular nodes just represent that this is a country, and the place node which are red, they represent its outbreak area. So these all about the nodes in our knowledge graph, and let's see that how these entire nodes are related to each other. See, this is the beauty that animation, especially I like it. So, so if you see the sample knowledge graph, so you see there is a country which is connected by a airport, and then there is a person who has traveled from that country. He has met another people. So likewise, we have formed an extensive relationship among the people, and even they have visited many other locations also. So that will be shown by the visited events. So like this. So now our main task is to analyze the particular individual behaviors. So I'm just going to see the one individual and see how the contact tracing can be done. So this is one my point of interest that I'm just bringing. So this is person 16, and these are their details. COVID symptom is true. It means that he's a positive person, COVID positive, and we use some identifier like mobile number and national ID. We even have a risk score and social distancing score that I will talk about. So let's see that who all people came in the contact of this particular person. So, so these it means that this particular person 17, 19, and 18, this came into the context. So it means that for health authorities, these people must be quarantined. And if you want to see when they have met this particular person, we can explore the met event. So see this particular event, it is telling that they have met on 13th June for the 10 minutes. So we are also storing the at what how much duration they are spending for our calculation purposes. Now, if you want to explore the entire chain, so I just go and say that okay, let me see where person 12 has met. So now you see the chain is getting increased. So it means that it is very likely that 16 has met person 12, and the person 12 has met other people. So it means that this entire chain of the people has to be quarantined. So for person number 19, this is the first level contact, this would be the second level contact, and this would be the third level of contact. So likewise we can go and explore the entire chain, and by that's how you will we will identify who would be the super spreader in that. So this is about the individual analysis. What about the location? So let's go and explore that. So we'll go to different perspective location. So first let me list down the location in my graph. So if you see here, the blue nodes actually represent a location and the red nodes are location, but these are the outbreak areas. So for our interest, government especially wants to know that who all are the people who has visited any outbreak area, so that they can be notified and they can be quarantined, or they can be notified to take the precautions. So let's see who all are the people who has visited. So now if you see these many people has visited, and it's very likely that few positive person has visited. That's the reason why it become outbreak. So now if you see the what is the event when they visited, so that can be also seen. For example, this particular person has visited and he spent 60 minutes, so that's a very long time. So that could be one reason why this become outbreak area. And if government, if health authority wants to know, track down that this particular person has visited this location and where else he has visited, so they can go and explore other visited place. So now you see that this particular person has even visited a airport as well as another store. So likewise, government health authority can easily predict which all the location could be the possible outbreak area. So we can do location analysis from the Bloom tool, or we have specialized tools like NeoMap that actually give you the geolocation based analysis. So, for example, this particular map just telling you that these red dots are representing which all the locations positive person has visited. So if I explore this particular location, it tell that the location, it tell the risk score of the location. It means that the risk of visiting that place is around 55%, and there is a 1% positive person has visited. So likewise, the health authority can visualize the movement of positive person over the graph. One of the innovation that we did is especially problem is that when you store a GPS location into a graph, even a decimal changes in the coordinates will result a different geolocation coordinates, and it was almost impossible for us also to store all the information. So what we did is that we analyze a very unique method that call as hexagonals. So we use Uber S3 hexagonals that tell that cover entire Earth into a hexagonals, and we can call especially a cell. So that cell has certain parameters. So the benefit of that is that if, for example, this particular cell has a size of around 100 square meters, so it means that all the GPS coordinate belongs to that particular location will be just point to one particular centroid. So instead of storing all these particular locations, we will store the centroid of particular cells. So that's how we were storing the centroid of cells into a graph, not exactly the person's GPS location. So that was one of the good way to store the GPS location into a graph. So now I'll go back to the graph. So that's how we were doing roughly the location analysis. Now, let's talk about the social distancing score. That is one of the interesting thing that we really did. So let me just see the list of all people first. I think you will be impressed by the coloring that especially we like it. So this coloring is especially for a fact that it explains that there is a propagation of risk. So the red notes actually telling that there is a COVID positive person at high risk. The orange notes are telling that there is a medium risk person, and the green notes are telling that there is a low risk person. So, for the health authority, especially the vaccination drive, the mass testing, the government can prioritize the list that who all are the people who can be tested first instead of just preparing a random list and then start doing the testing. And this behavior can be explained why this particular person is risky, that can be easily explained in the graph. So if I explore the one particular person behavior, so now if you see that why this particular person has positive, because he traveled from a country, Italy. So initially Italy was one of the country having the very high COVID rate. He even met another person who was positive. He even met lot of people. He visited outbreak area. So that's the reason his score is very high. And if you see the score, it's 1. So it means that he is at high risk, and his social distance score is 0.825. It exactly explains that he's a very socially active. He keep going outside, and there is a very likely he may have infect others. What about the medium risk person? So let's explain them. So if I see the behavior of this particular person, so he actually met one of the positive person. That's why his score is in average like 65%. And so these people need to be prioritized first for the vaccination or for the mass testing. If we see the people who are very safe, followed a safe social distancing, then that behavior can also be expanded. So the reason why his color is green and he's safe because he just met another person who is also very safe, who has followed all the social distancing rules, and he just visited one particular location. And if I see the score, it's just tell that risk score is 32%, and his social active score is also very less. So that's how the government or the health authority can track down their movements as well as prioritize the mass testing. Now let's explore another case that we were working is travel history. So let me just find out the list of people who travel from another country. So these many people actually travel from another country. So initially it was very important for government to understand the behavior of the people who travel overseas, especially from other countries. So if you see here, there are people who travel from Bahrain, all are positive. There are people who travel from China. There are people who travel from USA, and there are people who travel from Italy, all are positive. So let's explore one of the nodes and see, especially the China, that how it is correlated, how it is related to Saudi Arabia. So if you see, it is connected to two of the airports, and these two particular person has visited the China, and then this if I have to understand the behavior of this particular person 36, what he did after coming from China, then I can see. So this exactly explain that he visited one outbreak area, and he met another person 31 who is a positive. So this is all about our location analysis. Now we are going back to the slides where I will conclude my talks and our learning experience from that. Okay, so from that particular learning, we took the knowledge graph to a next level. We are just building a cool stuff like traffic simulation and congestion management. And we are also doing one sub part of that particular project is urban planning and landscaping. So if you see particular image that is quite familiar to you, it's exactly like a Google Maps. So where when you are traveling, you just see the red lines that shows you there is a congestion, then followed by orange and blue lines that shows the level of congestion severity. So same we are trying to implement a simulation where we try to understand the congestion, what would happen, the congestion effect of congestion on other nodes, and what happen if there is accident, what would be the effect of the entire graph. So this is what we are trying to build, and we are very excited for that. So on the node level, if you see, so each junction are exactly the nodes that represented by blue nodes. So actually blue nodes represent that there is a no congestion between the two particular nodes. That is followed by orange that shows that there is a medium level of congestion. And if you see the red dots, that shows that there is a high congestion on that. So we are exactly building a similar to a Google map for our own purposes. So from all these efforts, our learning is that we build the entire graph within a 2 to 3 months, and the Neo4j was the core of our application. We use extensive libraries, and we use a knowledge graph pathway that established to do a further POCs, and that we are doing especially for the traffic simulation. So we are very excited for that. So this is all about our talk, and thank you so much for listening.